Here we have AMC math problem. Okay, let's go to the question. For some real numbers a and b, the equation over here has three distinct positive roots. If the sum of the base two logarithms of the roots is 5, what is the value of a? Okay, here we have a cubic equation, and usually we have three roots for a cubic equation. When I find sum of the base two logarithms of the roots is 5. Okay, now let me assume R1, R2 and R3 are the three roots of this cubic equation. Okay, now let me take a base 2 logarithm for each of the three roots over here. That is a log base 2 of the first root R1 and a log base 2 of the second root R2, log base 2 of the third root R3. Now let me get the sum of the base 2 logarithms of the three roots. Okay, here this one equals to 5 according to the information we have. Here we are adding three logarithms with the same base 2. Whenever we add two or more logarithms with the same base, what we can do is we can take logarithm once with the base, what we have for all the logarithms over here, and we have to multiply the arguments. That is R1 times R2 times R3. So I got this result using the product rule of logarithms. That is, we add two or more logarithms at the same base, we take logarithm once and we multiply the arguments. Okay, on the right side we have 5. Here we have the equation in logarithmic form. Let's convert this equation to exponential form. For that, we have to move this log along with the base 2 to the right side of the equation. When I move this one to the right side of the equation, we have to ignore this logarithm. We have to consider only base 2 on the right side. The value which already exists on the right side will become the exponent of this base. Then we get 2 to the fifth power on the right side. On the left side, we have this stuff. That is R1 times R2 times R3. Okay, R1 times R2 times R3 equals to 2 to the fifth power is 32. Okay, now let me consider the general form of a cubic equation, that is ax cube positive, bx square positive, cx positive, d equals to 0. Okay, when we have a cubic equation in this form, there is a formula to get the product of three roots of this cubic equation. The formula is a negative d over a. That is, we have to take a negative sign. The constant term has to be divided by the coefficient of x cube. Okay, now using this stuff, let me get the product of the three roots of the given cubic equation. Okay, now let me do it over here. That is R1 times R2 times R3 equals to, we have to take negative sign and we have to consider the constant term in the given cubic equation. Here in our cubic equation, the constant term is a. It has to be divided by the coefficient of x cube, that is 8. Okay, here I got the value of R1 times R2 times R3, that is 32. Here also I got value for the same stuff, that is R1 times R2 times R3, that is negative a over 8. Okay, here this negative a over 8 and 32, both of them are the values of the product of the three roots, so we can equate them. Then I am getting negative a over 8 equals to 32. Now let me multiply both sides of this equation by 8 to get up the denominator over here. Then 8 will cancel out. I am getting negative a. When I multiply 32 and 8, I am getting 256. Okay, my aim is to get the value of a. Here we have negative sign in front of a. To get rid of this negative sign, let's multiply both sides of this equation by negative 1. When I multiply this one by negative 1, I am getting just a. When I multiply this one by negative 1, I am getting negative 256. Okay, here I got the value of a. It is a negative 256. We find this negative 256 in answer choice A. The correct answer choice for this question is A.